All right, so I had a couple questions from section 2. And so these are dealing with proportions. First, it's a proportion, and that first one is always equal to. It's believed that it was 4% in the past, and we're going to do a sample to see if it's still 4%. An obstetrician believes that the percentage of mothers who smoke 21 cigarettes or more is less than 4% today. So maybe through marketing and stuff out there that people know cigarettes are bad for you, maybe it's less than. So we'll check that. And then find a p-value. So I'm going to go to my stack crunch. So let's look at our information. A sample size of 135, and 4 of them smoke 21 or more cigarettes. So 4 out of the 135. So in stack crunch, I go to proportion stats because I'm dealing with proportions. I have a summary. That's 4 out of the 135. Our believed proportion was 0.04%, and we said we think it's less than because of awareness. Maybe less people are smoking. So we get a p-value of 0.2693. So what that 0.2693 stands for, 0.2693 to 3 decimal places, 0.269. Uh-oh. Less than 4%. Let me check my inputs. 0.269. Said less than 4%. Huh. Well, maybe that's why the person had the question with it. Interesting. Whenever this happens to me, I kind of go back and look at, does it satisfy that n times p times 1 minus p has to be greater than or equal to 10? If it doesn't, we may have to do something else. So let's see. So my n is 135. My p is 0.04. And my 1 minus p is 0.96. So this has to be greater than or equal to 10, and it's not. Alright, so that's going to change how we do this problem. So let's look in the book. Let's see if we can find out where the book will help us out in this section 2. Alright, oh, way off on chapters. So, chapter 10, section 2. And so we always have to check those conditions, so you really do have to be careful when doing these. Let's see. Let's see if I can find it in the book. Again, they're always telling us to check. And I think when we do these, what we're going to have to use is the binomial to give us the information. And here we go. So for the sampling distribution, we require that it be at least 10. What if the requirement is not satisfied? So that's when we'd actually have to go to our binomial calculator to figure this out. So let's go to our binomial calculator, and we had 135. The probability we're saying is 0.04, and we want to see that was less than or equal to 4 to see what that number was. Now we had 0.269 a second ago, but with the binomial we get 0.369. So let's check that answer out. Let's see if we're on the right path. 0.369. And that's what it is. So again, when I missed it the first time, I did the same thing probably as a student who emailed me. I did not check that n times p times q has to be greater than or equal to 10. And so I have to use the binomial calculator to figure that out. And my percentage is 0.04%, and I would do less than that 0.04%. And so is there sufficient evidence? And my p is not low. I would not reject. There is not sufficient evidence. So we could state that. 13 was another one they had issue with. Let's see if it's possibly the same thing. Here's our percentage. Here's our sample size of 70. So a sample size of 70. My percentage is 0.114 times 1 minus that. I'll have to write this one out. 1 minus 0.114. Let's see if we get, yeah, I see we don't get less than or equal to 10. So again, it was 10 out of 70 and 11.4%. So when we go to our calculator, we would say 70.114 and 10. And that's how we're going to find our p-value. 0.830. So those are the ones you kind of got to look out for. And then lastly, there was one, number 15, that p equals p naught versus p not equal to p naught, for p not equal to being 0.46, 0.47. So we got to try all these, right? And we have to see on which ones do we reject the null hypothesis. So we're just going to do this repetitively, right? In StatCrunch, we're going to plug in our values of 57 of 100 individuals, right? And so proportion stat was summary. We had 57 out of 100, which is 57%, right? But when we check it, I think the first one they said to check is 46, and then try 47. We're trying to find the values of p naught. Do you not reject the null hypothesis, right? So we would try first 0.46. Let's make sure it's a not equal to. And it's a not equal to. So we check, we look at our p-value. That is a reject, right? When my alpha is, let's find my alpha is 5%. So it's not 46. So let's try 47. Maybe I'll reject, or will fail to reject then. Nope, 0.04, right? So we're just checking to see what would that believed proportion have to be for me to receive 57 out of 100 and say that I really don't think it is 48%, right? Or I really do think it's 48%. So at 48%, and I get a sample size of 57 out of 100, my p-value is not low enough to reject the null hypothesis. So we're just having to do some repetitive work here. This lower one would be 0.48, and I think the upper one would be 0.66. could check those by just inputting them in. So it just takes some extra work on this one. But great question. Again, I got it wrong the first time. Check your n times p times 1 minus p. Has to be greater than or equal to 10 to use the normal distribution, which we're using in the proportion stat.